Welcome back for the video for lesson 2.2. This video is all about formulas and how to solve for different variables in the formula. So a formula is used when you want to repeat something with different inputs, such as a formula to change from Fahrenheit to degrees in Celsius. If you had different Fahrenheit temperatures and you wanted to switch those over to degrees Celsius, a Fahrenheit or a formula for Fahrenheit would be really good to use because you can repeat the process over and over again with the formula. It's like a recipe to make blueberry muffins, right? You can repeat that formula or that recipe over and over again with different maybe fruits instead of blueberries. So let's look at some examples. So we have this equation here. It says y equals 2x minus 3. And we know that y is going to equal 0. So solve for x. We are going to replace the y with 0. So I rewrote the same equation, but instead of y, I put 0. Now we're going to isolate or solve x is the final goal. So we want x to be alone. So we're going to add 3 to both sides. So I added 3 to the left because I'm going to add 3 to the right so that this adds to 0. Then this arrow tells us that now we have 3 on the left because 3 plus 0 is 3 equals 2x because the minus 3 and the plus 3 added to 0. Then to solve for x, we're going to divide by 2. Because this one, we want this to be a 2 divided by 2 is a 1 on the x. So we have to divide by 2 on the left. So x equals 3/2. So for example 2, we're going to use the same formula or the same equation, except for this time, we're going to let y equal a -3. So again, I'm going to replace y with my -3. And then my steps to solve for x are going to be identical to up here because I have to do the same process. It's just I want to equal the -3. So again, I have to add 3 just like I did up above. Okay. And so that is going to result in the 3's cancel again. This time I have a -3 plus 3. So now my left equals 0 equals 2x. And to solve for x, I'm going to divide by 2. And 0 divided by 2 is just 0. So x equals 0. So I use the same equation or the same formula with 2 different inputs for y to solve for x. So now this time, we have an equation here in example 3 that says if x minus 2y equals 4, and we know that x equals 8/5, find out what y needs to be. So I'm going to replace x with 8/5. And I want to solve for y this time. So because we have a fraction, I'm going to multiply through by that denominator so that I can eliminate my fraction. So I'm going to multiply this fraction by 5. I'm also multiplying this 2y times 5 and then the 4 times 5. So these 5's cancel and I have 8 subtracting 5 times 2 is 10y equals 4 times 5 is 20. So to solve for y, I'm going to undo this 8 first because I need to get all the constants over to the right, away from the variable. So I'm going to subtract 8. So the 8 minus 8 equals 0. So I have a -10y equals 20 minus 8 is 12. I'm just going to rewrite it. So now to finish solving for y, I'm going to divide by this -10 so that a -10 divided by -10 is a 1. So we have 1y, or just y, and then I'm going to divide by negative 10. So I'm going to have a negative 12 over 10. So y equals negative, and I can reduce my 12 over 10 by a factor of 2. So I have 6 over 5. Okay, example 4, I have a formula to find R. So right now the formula finds D. If I know R and C and T, I can find D, but I want to find R. So let's first replace all my variables with what I do know. So I know D, so 49 equals, I don't know R, but parentheses R minus C is 4, and T is 3.5. Okay. If I did know R, I would subtract 4 and multiply by 3.5, but I don't know R. So I am going to distribute this 3.5. So 49 equals 3.5 R minus 4 times 3.5. So 49 equals 3.5 R minus 14. So to solve for R, we're going to add 14 to both sides because my R's, my variables, all on one side. I need to get my constants to the other. So I'm going to add 14. And remember, you only do the opposite action if you're moving across the equation. So because I want to move my constant over to the left-hand side of the equation, I have to use the opposite action. So from subtracting 14 to adding 14. So I have 3.5 R on the right, and now I have 49 plus 14 is 63. So to solve for R, we are going to divide by 3.5. Again, I want to get rid of my 3.5 and move it to the left. And because I'm currently multiplying right here, my opposite action is to divide. So this one I cannot do in my head, so we are going to go to Desmos. And I want to make sure I did that correct. So then we have 63 divided by 3.5 is 18. And remember, if you're working in Desmos for any lesson, it's good for you to just go ahead and save that as lesson 2.2. So if I divide by 3.5, R equals 18. Let's take example 5. Example 5 says, if D equals K times T squared, find K if we know T is 2 and D is 64. So let's go ahead, and the first step is just to replace what we do know. So D is 64. I don't know K. And because there's a multiplication going on here, I'm going to put it in parentheses. T is 2. And also because I'm squaring it, it's nice to kind of put it in a parenthesis and isolate so I know exactly what's being squared. So I'm going to simplify what I can. 2 squared is 4. And then I like to write my coefficient in front of the variable. Remember, a coefficient is the number in front of the variable. Co means to go with. So the number goes with the variable. 4 goes with the K. It tells us that we have 4 Ks. Whatever K is, we have 4 of them. And I want to find out what 1K is. So I'm going to divide by that 4 to find out that 1K equals 16. So we've got some more here. Okay, I'm going to move on and then I'm going to make a second video that has the filled in problems of some extra ones that you might want to get. So let's move to B. B says rate equation and average speed. So D equals RT is the equation for distance equals your rate times your time. So it says it takes a boat 6.5 hours to travel 117 miles upstream against the current. If the speed of the current is 5 miles per hour, what is the speed of the boat in still water? Okay. Upstream means you're going against the water, against the current. So that means you're being slowed down. You're being slowed down by the current. Still water means as if there were no current pulling you or pushing you. Okay. So time is 6.5 hours. And distance is 117. So I know my distance. And speed is the rate. Okay, so I don't know my R. So R is, and it's going against the current. So the current is 5 miles per hour. So whatever my speed is, I'm losing 5 miles per hour. So I'm going to subtract that 5. I'm losing 5. And I know that my time it took was 6.5 hours. So these take a little bit of practice. So reach out if you need some help setting these up. So to solve for R, we're going to first distribute the 6.5. So 117 equals 6.5 R minus 5 times 6.5 is 32.5. And then to solve for R, we're going to add 32.5 to move the constant to the left. So that is 149.5 equals 6.5 R. And then we're going to divide by 6.5 to solve for R. So let's go ahead and go to Desmos to do that. So it looks like my rate is 23 and it's miles per hour because those were my units. Because 117 is distance and that's miles. So we had miles equals my rate. We'll figure out that unit here in just a minute. Minus 5 times 6.5 is time, and that was hours. And we ended up dividing miles divided by hour. So it's miles per 1 hour. Next example, a cyclist takes 3 hours to travel 39 miles while pedaling against the wind. If the speed of the wind is 4 miles per hour, how fast would the cyclist be able to travel on a windless day? Okay, so we've got another distance equals rate times time. And they said against the wind. So it's kind of like our last one where the current was slowing us down, and now it's the wind is slowing us down. It's against the wind. So whatever our speed is, we have to subtract 4 because of the wind. So our distance was 39 miles. Our rate, we don't know, but we have to subtract 4 because of the wind. And then the time it took us was 3 hours. So let's distribute the 3. So we have 39 equals 3r minus 12. I'm going to add 12. And so we have 51 equals 3r. And to solve for r, we're going to divide by 3. Having some colored pens or pencils might be helpful so that you can see what you're doing and things, the steps that you're taking. And so r is 17, and it's again miles divided by hour. So it's miles per hour because we divided it, so it's a unit rate. 17 per 1. Because it's per 1 is a unit rate. So I'm going to do a couple of these, and like I said, these examples here are examples of formulas you might have to solve later in the semester. So it's good to get some practice just solving formulas. So it says they want us to solve each of these formulas for y. So let's do this basic one, and then we'll do number 2. And then I'm going to have the second video is just an extra video to finish up 2.2. So if we want to solve for y, we're going to subtract 1. And since we don't know what x is, we're going to say it's just x minus 1. So we're putting the equation in terms of x. So we're solving for y in terms of x, meaning if we knew what x is, we could find y. So because I'm still solving for y, I'm going to divide by 4. So x minus 1 divided by 4 equals y. Problem number 2. We have fractions involved. So I'm going to distribute first, and then I'm going to multiply through by my fraction. Actually, let's just go ahead and divide by the denominator now. So our denominator, we only have one fraction, so we're going to multiply through by 4. So 4 times this entire y minus 1, and then 4 times the fraction of 1/4 times x minus 3. And so we only have to multiply through by this 4 once here. So I'm going to distribute on the left. So we have 4y minus 4. And then this cancels. So we just have x minus 3. And they wanted us to solve for y. So we are only concerned about getting y by itself. We're not going to worry about x. So I'm going to add 4 to both sides. And I have a constant on the right, so I'm going to combine the -3 and the 4 because they're both constants. Constants meaning they're numerals, numbers, all by themselves. So now on the left, we have 4y equals, and then x, a -3 and a +4 gives me +1. Gonna rewrite it. Solving for y means we're going to divide by 4. So we have y equals x plus 1 divided by 4. And you can also write that individually as x divided by 4 plus 1/4. Or you could write it as y equals 1/4 x plus 1/4, pulling the 1/4 off to the side. So there's 3 different ways that you could write this. Here's 1, here's 2, and here's 3. So catch me back for the second video if you need some extra help.